In this video, we're going to talk about lists, tuples, and dictionaries, structures for saving and indexing groups of objects. Please continue to work with the notebook from the last session, Notebook 1.1, Introduction to Types and Operations. So we've already seen a few examples of lists in the previous video, however all of these were lists of integers. In practice, lists can contain anything: integers, strings, floats, mixed data types. They can even contain other lists, where this practice of containing objects within other objects is known as nesting. Lists are sequential data objects, which means that they can be indexed like an array. And like an array, lists and strings index from 0. So this means that if we want the third item of integer list, which as you can see is a 3, then we must index it with the number 2. Likewise, the object corresponding to the third index of mixed list is the fourth item, which is the number 2. Strings can be indexed in the same way. So the sixth index of the string variable known as testString is the 7th character, which inclusive of the space gives us the capital letter W of world. Indexing can also be ran in reverse. So if we want the last item of a list, we can use the index -1. As sequential data objects, this means that lists and strings can also be sliced into different subsets. So the syntax for this is to define a range which is inclusive of the first index and exclusive of the last index. So taking as an example a slice from the integer list in the range from 2 to 4, and reminding ourselves that indexing starts from 0, what this means is that we're going to take the subset of values corresponding to the second and third index, that's the values 3 and 4, not the fourth index, as the slice is not inclusive of the last value in the range. For the second example with syntax :5, this indicates that we want all values up to but not including the 5th index or 6th value, so that's the numbers 1 to 5. And the third example shows that if you don't specify the end index, it's going to assume that you intend the slice to stretch all the way to the end of the list. So this slice takes all values from the 4th index or 5th value to the end, which returns a subset 5 and 6. Finally, the fourth example asks for all values in the range from the 4th index to the penultimate value, as it is exclusive of the final index in the range. Given that the 4th index in this example is the penultimate index, this means that the slice is going to return only the penultimate value of the list, which is the number 5. So now what I suggest you do is go to the notebook, section 1.5.1, and try out a few different slices of the lists in the notebook to see whether they give you what you expect. Moving on now to assignment. So it's possible to increase the length of a list using the method append. So for example, here we can append the value 7 to the integer list. In case you're wondering, you can also insert values into the middle using the insert function, although I've never had cause to. To return the length of a list or a string, you can use the len function. And if you want to combine 2 or more lists, then you can do that through the concatenation operator given by the plus sign. Another interesting property of lists is that they're mutable. So that means that you can swap items out from a list and replace them with new ones. So taking as an example this list of strings, we can swap the second index or third item for the integer 3 to return a mixed list. On the other hand, strings are immutable. So this means that if we attempt the same operation on a string to swap out the second index with the character A, it will throw an exception saying that string object does not support item assignment. In other words, it's immutable. So this brings us on to tuples. So tuples are very similar to lists, the only difference, other than the syntax, being that they are immutable. This creates an object which can be faster to index or search than a list, and for that reason they can sometimes be useful for improving the runtime of programs. Finally, dictionaries. These are used to store unstructured data, In other words, data for which there is no clear sense of order or sequence. For example, here we have a collection of variables describing some individual, such as names, age, employment, or height. Another example might be a collection of meta-information about an image file. As dictionaries are unordered, they're not sequential, so this means that they cannot be indexed or sliced. Rather, objects stored in dictionaries are referenced using key lookups, similar to a MATLAB structured array. There are several different styles of syntax for creating dictionaries, so this is one example. So you can create an empty dictionary using the syntax of the curly brackets. To create new key lookup pairs, we call the dictionary and create a key name indicated within the square brackets. So here I have my dictionary, square brackets, and I've created a key which I've called name. I then assign a variable, string, Dave. So here, name, age, job, and height are all keys, and Dave, 23, lecturer, and 190, they are the objects that we've assigned to these keys. So here's a different notation where everything is defined in line, with lookup object pairs separated with commas, and keys preceding their objects, each separated with a colon. Note the keys can be any immutable type, so that includes integers, floats, and tuples. However, logically they're most often strings. The objects are mutable, so you can change their value. For example, we can change this person's name from Dave to John. We can also delete keys using the del keyword and append the dictionary with new keys at any point during runtime. For example, here we've added a new key, phones, with a list of phone numbers. Finally, what happens when you try and create a key that hasn't been defined? It's going to raise a key error exception. Dictionaries are unordered, so that means they're impossible to search through sequentially, index or slice. However, methods for iterating through a dictionary do exist, and they will be described in the next lecture. However, other methods that apply to lists, strings, and tuples do apply to dictionaries, so you can ask a dictionary what its length is using the len function, and you can check whether a key is in a dictionary using the in operator. So that's the end of this video on lists, tuples, and dictionaries. These structures are all used for saving groups of related objects. The key differences between these objects are that lists and tuples are sequential data structures, whereas dictionaries are not. Tuples are essentially lists that are immutable, so this makes them faster to index, which can be useful when runtime is important. Sequential data types such as lists, strings, tuples, and arrays may be indexed, sliced, and iterated through in order. On the other hand, dictionary variables are accessed through keys. So this is the end of this video. Please run through the quick Keats quiz to check your understanding before moving on to the next lecture.